Hey, how's it going? I'm Darian, part of Team 1 in NOAA's 1030 lab, and I'm in charge of results and discussion.
Hi, my name is Aina, and I was in charge of the abstract, relevance, and references in the lab report.
Hello, my name is Francis Cabello, and I was in charge of the production and the edition of the video of the project.
Hello, my name is Rebecca Hall. I was the project team lead, and I was in charge of doing all of the Arduino builds, the code, and collecting all of the data for our experiments.
Hi, my name is Gage, and I was in charge of the introduction and experiment part of the lab report.
The goal of this project was to become familiar with the Arduino platform and the code used for it, while also gaining experience with creating experimental procedures and calibrating equipment. To do this, we are required to use an Arduino kit. 4 lessons were given to learn about different types of sensors that can be used, and the devices need to be calibrated, and the Arduino has to be programmed in order to carry out all the experiment. The requirements for the measurement systems that we have to build in this project was temperature measure system, a contactless distance measurement system, and a water depth system. Our initial plan to meet the project requirements was go over the lessons on class and follow their procedure to build every single system successfully, and combining different parts of the Arduino kit, like the servo, the LCD screen, the thermistor, or the water level detection sensor module. After to read the lessons for every single system, we could understand how to connect the parts properly following the wire diagrams. In the servo lesson, we connect the LEGO Uno R3 with the servo. In the thermometer lesson, we connect the LEGO Uno R3 with the board, the thermistor, and the LCD screen. In the water lesson, we connect the LEGO Uno R3 with the water level sensor, and in the ultrasonic lesson, we connect the LEGO Uno R3 with the ultrasonic port. All the systems were connected also with the computer running the respective code.
In the code, we simply take the input from our water sensor and then map it to the servo so that the servo itself will display between 0 and 180 degrees. There were issues when it came to coding the servo in order to get it to display as a dial. After doing some research through the Arduino site, I was able to find a useful function, the map function, that allowed me to format the input into a 180 degree display. One of the main issues we dealt with in the final build of the project was getting the servo to work in combination with the other sensors. We were able to get it working by using the breadboard to expand the 5-volt source so that we could use the 5 volts for multiple sensors and the servo. The thermistor itself was very finicky as it was in the breadboard, so bumping it too much could influence the data received. The thermistor also did not go down to lower temperatures, so when an attempts to calibrate with an ice cube at room temperature, the thermistor would not drop down below more than 7 degrees Celsius without crashing to -275. A problem that likely influenced the data we collected was an issue with the water depth sensor. It seemed after using the water depth sensor multiple times, even after drying it off, that either through overheating or overuse, the signals it was displaying were much higher than what was expected, and it made large jumps straight from 0 to 300 plus. In order to calibrate the ultrasonic sensor, I set up a ruler in order to measure the exact distance from the ultrasonic sensor, and then used a flat sheet of paper at different lengths on the ruler, and then compared the data that was received through the Arduino to the measurements on the ruler. Calibration test. In order to calibrate the water depth sensor, I added measurements to the side of a clear cup at 1/2 centimeter intervals, and then dipped the water sensor in and compared the output from the Arduino with the measurements on the side of the cup. To calibrate the thermistor setup, I used a standard under the tongue thermometer held in between my fingers to get a base measurement, and then I held the thermistor between my fingers to get the thermistor Arduino measurements. I did this multiple times.
The impact of being able to finish this project is huge for the whole team. Every single lesson teaches important topics for our future careers, from create a code to communicate sensors with rotors and screens, to understand how different kinds of circuits can be created to build a system. These practices are going to be doing for us in the future jobs, from measure the temperature of a mechanical piece while they are realizing a job, to check the depth of a fluid in a tank. We just simply need to finish this video saying thank you for all the experience that you teach us in this class.